Hello and welcome back to Chopstick Maths. In this video, we shall solve a problem from the chapter of exact differential equation, exercise number 1, sum number 12. The given equation is y sine xy plus xy square cos xy into dx plus x sine xy plus x square y cos xy into dy is equal to 0. Now the given equation is of the form m dx plus n dy is equal to 0. So let us first prove that it is an exact differential equation. So here m is equal to, so comparing this equation with m dx plus n dy is equal to 0, we get m is equal to y sine xy plus xy square into cos xy. So we will first take the partial derivative of m with respect to y, that is del m by del y, and that is equal to del by del y of y sine xy plus xy square cos of xy. Now if you see this term, it's a product of an algebraic term y and a trigonometric term sine xy. So to partially differentiate this with respect to y, we'll have to use the product rule. So this will be y into del by del y of sine xy plus sine xy into del by del y of y. Again, this term has x, a y square and cos xy. Now x is a term which has to be treated as a constant since we are partially differentiating with respect to y. Now y square is an algebraic term and cos xy is a trigonometric term. So to differentiate this, we'll have to use the product rule. So keeping x outside as a constant and applying product rule to differentiate y square cos xy, we get y square into del by del y of cos xy plus cos xy into del by del y of y square. Now, this would be y, and del by del y of sine xy is cos xy into the partial derivative of xy with respect to y. But since we are differentiating partially with respect to y, we'll have to treat x as a constant. So this would be x into del by del y of y plus x sine xy, and del by del y of y is 1, plus we keep x outside as a constant, and here this would be y square. Del by del y of cos y is minus sine xy into the partial derivative of xy with respect to y. Now we'll have to treat x as a constant. So this would be x into del by del y of y plus cos xy, and del by del y of y square would be 2y. So we can write this as y cos y, x into del by del y is 1. So this would be y cos xy into x into 1 plus sine xy plus x into the bracket minus y square sine xy, and del by del y of y is 1. So this would be into x into 1 plus cos xy into 2y. So we write this as 2y cos xy. Now this can be written as xy cos xy plus sine xy, and opening the bracket here, this would be x square minus x square y square sine xy plus 2xy into cos xy. So finally the partial derivative of m with respect to y, that is del m by del y, is equal to 3xy cos xy, because xy cos xy and 2xy cos xy are like terms, they can be added. So we get 3xy cos xy plus sin xy minus x square y square sin xy. So we can write this as 1, and this is del m by del y. Now, n equals to x sin xy plus x square y cos xy. We have to find out the partial derivative of n with respect to x, that is del n by del x. And that is equal to del by del x of x sin xy plus, now we have to treat y as a constant since we are differentiating partially with respect to x. So this would be y into bracket del by del x of x square cos xy. Now, this is a term which is a product of algebraic term x and a trigonometric term sin xy. So we'll have to differentiate this using partial derivative. So this would be x del by del x of sin xy plus sin xy into del by del x of x plus, keeping y outside as a constant, we'll have x square del by del x of cos xy plus cos xy into del by del x of x square. Now, this would be x, del by del x of sin xy would be cos xy into the partial derivative of xy with respect to x, but keeping y as a constant. So this would be y del by del x of x plus sin xy, and del by del x of x is 1, plus keeping y outside, this would be x square del by del x of cos xy is minus sin xy into the partial derivative of xy with respect to x. So we have to treat y as a constant. So this would be into y del by del x of x plus cos xy, and del by del x of x square would be into 2x. So we can write this as x cos xy into y del by del x of y, x del by del x of x is 1. So this would be x cos xy into y into 1 plus sin xy into 1, that is sin xy, plus y into bracket x square into minus sin xy, that would be minus x square sin xy into y del by del x of x is 1 plus cos xy into 2x, which we write it as 2x cos xy. So now we can write this as xy cos xy plus sin xy. Now let us open this bracket. This would be minus y square x square sin xy plus 2xy into cos xy. So we can see that xy cos xy and 2xy cos xy are like terms, so we can add them up. This would be 3xy cos xy plus sin xy minus x square y square sin xy. So this is del n by del x, and we can call this equation 2. So from 1 and 2, we can conclude that del m by del y is equal to del n by del x. Therefore, the given equation is an exact differential equation. So now let us proceed to find the solution of the given differential equation. The given differential equation is y sin xy plus xy square cos xy into dx plus x sin xy plus x square y cos xy into dy is equal to 0. So the solution will be integral of m dx keeping y as a constant plus integral of n dy and integrating only those terms in n which are free of x, and that is equal to c, where c is some constant. Now, if you look, this is m. So the first term y has to be treated as a constant. So it would be outside the integral sign. So this would be y integral of sin xy into dx. Again here, the y square has to be treated as a constant. So this would be plus y square into integral of x cos xy dx. Now if you look at n, the first term has an x, the second term has an x. So both the terms, they have x. So we neglect both the term. So the integral of n dy is equal to 0. So this would be y integral sin xy dx plus y square integral x cos xy dx is equal to c. Now, if you look at this term x cos xy, this is a product of an algebraic term x and a trigonometric term cos xy, where y has to be treated as a constant. So you need the product rule to integrate this. So we can use this product rule. Integral of uv is uv1 minus u dash v2 plus u double dash v3, where the dash represents the derivative and the suffix 1, 2, 3 represents the integration. Now the condition for this kind of integral is u should be equal to x raised to n, where n is a positive integer. So u should be of the type x raised to n, where n is a positive integer. Now if you look at u, this is u is x raised to 1. So 1 is a positive integer. So u fulfills the condition, and v is an integrable function. So v has to be an integrable function. So cos xy is integrable because the integration of cos x is sin x. So cos xy is an integrable function. So even v fulfills the condition. So we can use this particular condition. So we can now use this uv rule. So let us separately integrate this. This integral of x cos xy dx is x integral of cos xy, that would be sin xy upon y, since y is a constant, minus taking the derivative of x, that would be 1, and now taking the integral of sin xy, that would be minus cos xy upon y, that would give you y square. Now the derivative of this would be 0. So the next term would be 0, as the derivative of 1 is 0. So we will stop proceeding further. So we have integral of x cos xy is x sin xy by y minus of minus cos xy by y square. So substituting, let us call this 4, substituting 4 in 3, we would get y integral of sin xy is minus cos xy upon y, as y is a constant, plus y square. Now integral of cos xy dx, we have already calculated. This is x sin xy upon y minus of minus cos xy upon y square, that would give you plus. So this would be y square into x sin xy upon y minus into minus would give you plus cos xy upon y square, and that is equal to c. So we can now write this as y and y would cancel out each other. So we can now write this as minus cos xy and into y square x sin y upon y plus cos xy y square. Now we are opening the bracket. So this would be y square cos xy upon y square is equal to c. So here the y would cancel out, and here the y square and y square would cancel out. So this would be minus cos xy plus y into x, that is xy sin xy plus cos xy. Now minus cos xy and plus cos xy will cancel out each other. So it will be xy sin xy is equal to c. So we can write it finally as xy sin xy is equal to c, which is the required solution for the given differential equation. Thank you very much for watching.